All right, let's get into it. Our bodies are constantly doing this incredible high-wire act with our main energy source, blood glucose. It's a super precise job, keeping our fuel levels perfectly balanced, and today we're going to break down exactly how it pulls that off.
You've totally been there, right? That irritable, hungry feeling we call hangry, or that, sluggish slump you feel after a big lunch. Well, those aren't just random feelings. Nope. They are direct signals from your body about this exact balancing act we're talking about. They're what happens when the balance tips just a little too far one way or the other.
So, here's the bottom line. For our bodies to work the way they're supposed to, from our brains firing off ideas to our muscles moving, our blood glucose has to stay within a really narrow, healthy range, not too high and definitely not too low. The steady supply of fuel is what powers everything we do. It's a constant challenge that our body is meeting, literally, minute by minute.
Okay, so let's start with one side of the story. Imagine it's been a few hours since you ate. Your energy tank is getting kind of low, and your blood glucose level starts to drop. So what happens next? Well, your body has a plan for this.
You can think of your pancreas as the mission control for your body's energy. It's constantly monitoring your blood, and when it senses that fuel levels are dipping, it knows it's time to act, and it sends out the first of our two key hormones.
And here is that plan in action. So as glucose levels fall, specific little cells in the pancreas, the alpha cells, they jump into action. They release a hormone called glucagon. Now, glucagon isn't the energy itself, it's the messenger. It travels straight to our body's main energy warehouse, the liver. And its message is simple: release the reserves. So the liver gets to work, converting its stored energy back into usable glucose and pumping it out into the bloodstream. And just like that, your levels are brought right back up.
And this whole process actually has a pretty cool scientific name: glycogenolysis. It's how glucagon indirectly gets the job done. See, it doesn't raise blood sugar by itself. It just tells the liver to do all the work. It's a really smart, super efficient system for tapping into our backup fuel.
Okay, now let's flip the script. You've just had a great meal. All those carbohydrates are being broken down into glucose, and a wave of new energy is surging into your bloodstream. Your blood sugar levels are on the rise. Now, this is the opposite problem, and it requires a completely different response.
Once again, the pancreas is mission control. But this time, a different set of cells. The beta cells sense that glucose spike, so they release our second key hormone, insulin. Insulin is the ultimate energy manager. First, it acts like a key, unlocking your body's cells so they can grab that glucose for immediate fuel. Second, it tells the liver to stop releasing glucose and instead start storing the extra, packing it away as glycogen for later. It's this amazing two-pronged attack that efficiently brings your blood sugar right back down to a healthy level.
And get this, it highlights something truly unique about insulin's power. While we have several hormones that can raise our blood sugar, insulin is the only hormone in the entire body that can lower it. That makes its job absolutely essential for our health.
So, we've got these two powerhouse hormones, glucagon and insulin. And yeah, they have opposite effects, but they're not enemies, not at all. They're partners, working together in this perfect complementary system to achieve one single goal: balance.
This slide just lays it out so clearly. On one side, you've got glucagon. It's triggered by low sugar, comes from the alpha cells, and tells the liver to release fuel, which, boom, raises blood sugar. On the other side, you have insulin. Triggered by high sugar, comes from the beta cells and tells your cells to absorb fuel and the liver to store it, which brings blood sugar down. It's this beautiful, simple push and pull system.
To really get how elegant this whole thing is, it helps to think of it less like a battle and more like a finely tuned piece of automated machinery. And the perfect analogy is probably something you have in your own home.
It works just like a thermostat. Your pancreas has a set point for your ideal blood glucose level. If the level drops too low, if it gets too cold, it turns on the heat by releasing glucagon. If the level spikes too high, gets too hot, it switches on the air conditioning by releasing insulin. It's always making these tiny, precise adjustments to keep you right in that perfect comfort zone.
And this right here is the genius of a self-regulating system. As this quote from our source material points out, the system knows when to shut itself off. Once insulin has done its job and blood sugar is back to normal, the pancreas just stops secreting it. The air conditioning turns off. The same thing happens with glucagon. It's not just on or off, it's a dynamic, constantly responsive loop.
So we've just seen how this incredible balancing act is supposed to work. This precise, automated system of glucagon and insulin keeps us fueled up and functioning at our best. But it leaves us with one critical final question. What happens when the thermostat malfunctions? Because when this perfect partnership gets disrupted, it can lead to serious health conditions, which really highlights just how vital this balance truly is.